Good afternoon. Welcome back to the second year zoology class. The last class we discussed about the LAQs and the SAQs also. The protein digestion SAQs we discussed. First I'll take the LAQ. Afterwards I'll take the first lesson SAQs. Next the LAQs already we completed in the circulation, body fluids and circulation LAQs we completed, and the excretory system also completed the one LAQ, and the next reproductive system 2 LAQs we completed, the male reproductive system and female reproductive system, and now we are going to third LAQ coming from the genetics. In the genetics. From the genetics, one LAQ is compulsory. That LAQ is the important LAQs are 3 are there in this. The most important is 3 are there. First is called as a multiple alleles. Multiple alleles. Second one, chromosomal theory of sex determination. Third one is the crisscross inheritance. These 3 LAQs are important. First, we discuss about the first LAQ, that is the multiple alleles. Multiple alleles. Normally, a gene is expressing, or a gene is having the 2 constant, the 2 forms, alternate forms are there, that we call it as the alleles. For example, this one is the chromosome. On the chromosome, the gene is present. Gene is expressing the one character. This character is having the 2 forms are there. These forms we call it as the contrasting forms are there. They are called as alleles. Different forms. For example, the stem height we can take, that is the one is a tall, one is a short, means the 2 contrast. The character is only the length of the stem, but the forms are 2 are there, one is a tall and one is a short. Like this, each and every gene is expressing each and every gene is having the 2 alleles are normally they are having the 2 alleles are 2 forms are present, and sometimes what will happen means they are having the more than 2 alleles, then we call it as a multiple alleles. Clear? A gene normally having a gene have normally 2 alleles. 2 alleles. In these 2 alleles, one is the dominant, one is the dominant allele, and another recessive. Which one is the expressing that we call as a dominant, another one is the recessive. Means the gene is having the normally genes are having the 2 alleles. One is called as a dominant allele, second one is called as a recessive allele. But sometimes they are having the more than 3 alleles. Here the gene is expressing the more than 2 alleles, means either 3, 4, anyone, that we call as the more than 2 alleles are there, that we called as a multiple alleles. Here we'll write it the definition. A gene has more than 2 alleles. In the name only it is there, multiple, more. Multiple means more they are there. The gene has more than 2 alleles. They are called multiple alleles. multiple alleles. The best example for the multiple alleles in the human being is the which one? The ABO blood group. Here, blood groups ABO blood groups are the good examples for the multiple alleles. See this one. This is the multiple alleles. What is the multiple alleles? A gene has more than the, leave it this definition, down definition is important. A gene has more than 2 alleles. They are called as a multiple alleles. The example is ABO blood groups. The multiple alleles, inside of the multiple alleles, the number of genotypes, clear? The number of genotypes in the multiple alleles, in the multiple alleles expressed by the one formula that is n into n plus 1 by 2. Means here I am writing here number of genotypes is equal to n into n plus 1 by 2. What is n? N is equal to alleles, number of alleles. Number of alleles. For example, normally we are taking we know the alleles are having the normal genes are expressing the one character that is having the 2 alleles are there. For example, how many alleles? Here we substitute here the 2 alleles. N is equal to 2. 2 into 2 plus 1 by 2. How much? Here it is the 6 by 2. Means 3 genotypes are formed. For example, we are taking the example of the stem height, tall and the dwarfed. Tall we are taking as a capital D, dwarfed we take it as a small t. The possible genotypes are in the monohybridization, you know about this one. They are having the capital T and the capital T small t and the small t. The possible genotypes, how many are there? 3. Like that, here the 2 alleles are there. The gene is having one is the capital T allele, another is the small t allele. 2 alleles are there. How many genotypes are possible? 3 genotypes are possible. Like this only, we are taking in this formula only, we substituted the blood groups. Means the blood groups are having the 3 alleles are there. Here, instead of here 3, the blood groups are the multiple alleles. That's why they are having the 3 alleles. What are they? A, B, O. 3 alleles are there in this. Here, that's why we are to substitute instead of this. Instead of 3, we are substituting here the n is equal to 3. 3 into 3 plus 1 by 2 means the 3 into 4 by 2 means 12 by 2 means the 6 genotypes are possible. I'll give detailedly how the six genotypes are possible. With the table I'll give this one is the formula. Multiple alleles means the gene is having the more than 2 alleles is called as a multiple alleles. The multiple alleles inside of the multiple alleles, number of genotypes identified by the formula n into n plus 1 by 2. Here the n is equal to number of alleles. Next, ABO blood groups. ABO. These blood groups are mainly depending upon here the ABO blood groups is here. The 4 types of the blood groups are there. A group, B group, AB group, and the AB group and O group. AB, O group. These four types of the four groups are mainly characterized by the antibodies, the presence and absence of the antibodies. Here, the A group, B group, AB, O groups are the four groups of the four blood groups are there. These are mainly characterized by the presence and absence of the presence or absence of antigen. Presence of antigen, they are characterized. Which one? If the A group is A antigen is present, the A group. B antigen is present, B group. Like that, the presence and absence of the antigen, the groups are characterized, or groups are divided. Next, how it is, what is the antigen means? In the blood groups, the antigen is present on the RBC. For example, here the inside of our blood, the RBC is present. Above the RBC, the antigens are present. Here above the RBC, antigens are present. These are antigens are the polysugars. These are the antigen present on the where RBC. This one is the RBC. RBC is having the membrane is there. That membrane we call as a plasma membrane. Plasma membrane. On the plasma membrane, this is present, that we call as antigen. This is a one type of protein, and it is made up of with the polysugars binded with the lipids. Here they are having the sugars and the lipids. Here this one is called as an antigen. Depending upon the presence and absence of the antigen, the these four groups of the blood will be divided. Here, for example, see. This is the antigen. This antigen, this is the RBC. Above the RBC, antigen is present. Already we discussed. Which antigen is present means, for example, here the A antigen is present. Here, that A antigen is present. That we call it as A blood group. Blood group is A blood group. A blood group means the antigen is present on the surface of the plasma membrane. Then we call it as A blood group. For example, on the RBC. On the RBC, here the antigen is present. That antigen is B antigen. If it is a B antigen, the blood group is called as a B blood group. B blood group. What about the AB means? Here the third condition, the RBC is having the A antigen as well as B antigen. Both the antigens are there. Then that blood group is called as the AB blood group. AB blood group. Next, the next one, the last one, the fourth blood group, that is called as a O group. Here, O group means which one? On the RBC. On the RBC, the no antigens. Here, normally the antigens are present, but here the antigens are absent. O group doesn't have any antigen. Here that's why called as a O group. No antigens are present, then we call it as a O group. If the A antigen is present, that we call as the A group. On the RBC, B antigen is present, B group. If both the antigens are present, A antigen as well as B antigen is present, that we call as a AB group. And the no antigens are absent, that group we call as a O group. Like this, the blood groups are mainly categorized by the presence and absence of the antigens. One more is there. The antigens, another name is also called as iso-agglutinogens. Here, these are called as a iso-agglutinogens. Means why we called as a antigens are called as a iso-agglutinogens means these are mainly give the clot to the incompatibility transfusion. For example, A group blood is given to the B group. What will happen? That is the incorrect blood group. That's why that time these antigens are giving the clot. Clot is given. That's why the name of another name of the antigens is called as a iso-agglutinogens. What it is? The blood groups are mainly the antigens are also called as the iso-agglutinogens because they give the clot with the incompatibility blood group. With the incompatibility blood group, they are giving the clot. That's why we call it as a agglutinogens. Next, inside of the blood groups, the one more antibodies also present. Clear? Here the RBC is having the RBC. The plasma membrane is having the antigen. What about the antibodies? Means, for example, see this one, the outside, this is the blood. Inside of the blood, the RBC is there. RBC is above the RBC, the antigens are present. What about the antibodies? Means the antibodies are present inside of the plasma. In the plasma, liquid is there in the blood. That inside of the plasma, the antibodies are present. Antibodies are present. For example, the D group is there. D group is having the opposite A antigen. Antibody, sorry. A antigen. It is having the, B group is having the antigen on the surface of the RBC. B antigen is present and it is having the anti-A antibody is present. Anti-A antibody is present. Next, in the A group, it is having the antigen A is present. And what about the antibody? Which antibody is present? Opposite. A means here it is the B antibody is present. Next is the AB group. What about the AB group? Inside of the plasma, the which antibodies are present means 2 antibodies are present. Anti-A antibody, no antibodies, Here the no antibodies are present. In this, the antigens are present. Both the antigens are present. A antigen is present, B antigen is present, but no antibodies. Next, what about the O group? O group on the surface of the RBC, no antigens and no antigens are present. Antigen and antibody is different. Here, which antibodies are present in the plasma? Both anti-A is present and also anti-B antibody. Both of them. Every time anti I am adding, that is antibody. Normally I am writing that we call as a antigen. Here, like this, the blood groups are mainly categorized by the presence and absence of the antigens. Here, next. Clearly, I am giving here, see this one. Clearly, I am writing here the groups, the A group and the B group, AB group and the O group. Just we are discussing about the antigen and the antibody. This one is, what about this First we take the antigen or iso-agglutinogen and the next is the antibody. Where the antigen is present? Antigen is present on the surface, means the plasma membrane of the RBC. Antibody is present in the plasma. Inside of the plasma, they are present. Clearly, I am explaining here. See this one. For example, a person is having the A group. A group person, they are having on the RBC, which antigen is present means same. A antigen is present. But the antibody is opposite, that is the anti-B antibody is present. Next, a person is having the B group. They are having the antigen on the RBC plasma membrane. They are having the B antigen is present. Antibody is the opposite, that is the anti-A antibody is present in the plasma. Next, AB group is having the both the antigens are present. A antigen is present and the B antigen is present on the surface of the RBC, and the inside of the plasma, no antibodies are present. That's why it is a universal recipient. Here, next, what about the O group? O group doesn't have the no antigens. A antigen is absent, B antigen is absent. That's why it is called as a universal donor. And here what about the antibodies means it is having the two antibodies, anti-A and the anti-B. This is about the categorized of the blood groups, multiple alleles. Good example is the ABO blood groups. The ABO blood groups are mainly depending upon the presence and absence of the antibodies. Next, the genetic basis of the ABO blood groups we are going to discuss. Genetic basis of the ABO blood groups. Genetic basis of ABO blood groups. ABO blood groups. That is explained by the genetic basis of the ABO blood group is explained by the Landsteiner. Here, Carlos Landsteiner explain about the genetic basis of the ABO blood. Before that, what we discussed, the four types of the blood groups are mainly depending upon the absence and presence of the antigen. But here, the genetic basis of the ABO blood groups, here he explained that is mainly depending upon the alleles, three alleles. Here, the ABO, the blood groups are categorized depend on alleles, depend on three alleles, depend on three alleles. Where they are present? Three alleles, they are present in the 9th chromosome. 9th chromosome is having the gene. Here, 9th chromosome having the gene. That gene is having the three alleles are there. Normally, all the genes are having the two alleles, but here the blood group expressing the gene is having the three alleles are present. These alleles only they categorize the blood group. Here, like this, for example, what are the alleles? Three alleles means I. The gene name is here we are taking IA, IB, and the IO. IO we write it as a small I also. Here, like this, three alleles are there. For example, IA, IB, they are having the antigens. These two alleles they are expressing the antigen. They are IA, IB means they are producing they are having the antigen A as well as antigen B. The IO that is not having the antigens. No antigens are present. Antigens are absent in the O. Means the allele IA, IB is giving the antigen A and antigen B, but the IO allele is not having the antigen. Here, next, depending upon that, a child is getting the any one of the three alleles. A child is getting the one allele from the each parent. For example, from the father, he is getting the one allele. Mother, he is getting the another allele. This is the one allele and this is one allele. Like this, the child is getting the one allele from one among the three alleles. The possibility of the how many possibility of the genotypes are there? We are going to discuss here. The IA means one is coming from the mother, one is coming from the father. Means the two alleles, for example, IA is there, or this is a homozygous. Sometimes one is from the mother, A is coming, from the father, O is coming. That time, this two types, we are called it as a group. Here, A group person may be having this type of the genotypes are present. Here, there may be homozygous or the heterozygous. Both of them are same, that we call as a homozygous A group, and this is having the different. Only one A is present here, O group. That's why we call it as a heterozygous A group. Like that only, B group is also having the one allele IB, one allele is the another IB. Next, IB, IO. Same like the A group. Here the homozygous, here also homozygous B group, heterozygous B group. Like this, here this one is a B group. Next is the AB group, means the IA is the one allele, IB is one allele. In this, only one is there, that is called as a one genotype is there, that we call as a AB group. Next, next is the O group, IO. It is a homozygous only. This is called as a O group. Here, like this, the possibility of the genotypes are 6. Already we discussed in the formula n into n plus 1 by 2. Means here the number of alleles, how many? Number of alleles are 3. 3 into 3 plus 1 by 2 means the 12 by 2 means 6. 6 genotypes are possible. See this one, 1, 2, 3, 4, 5, 6. Like this, 6 genotypes are possible in the 3 multiple alleles. This is the genetic basis of the multiple alleles. Before that, before we discuss about the normal, depending upon the antigens, we discuss. Next, compatibility. Blood group compatibility. For example, A positive blood group. A positive blood group. Taken blood from which groups is it is A positive, they can take, A negative, they can take, O positive, they can take, and the O negative. These 4 groups are suitable to the A blood group person. Here, A blood group means A blood group person taking the blood by the A positive, A negative, O positive, and O negative. Next, the A negative group. A negative group taken blood from blood group person, you add it. Person taken blood from, it is only the A negative group and the O negative group. Here, next we take the B positive blood group, taken the blood from the B positive, B negative, O positive, and O negative. Next, B negative taken from only the negative groups, that are the B negative and the O negative. Next is the AB positive. AB positive taken from which one? A group, A positive, A negative, B positive, B negative, AB positive, AB negative, O positive, O negative. Means from all the groups they can take. That's why this is called as a universal recipient. Universal recipient means from all the groups they can take the blood. They can. That's why it is called as a universal. Next one is the AB negative. AB negative only taken from the A negative, B negative, AB negative, O negative. Here, next remaining 2 are there. Next is the O positive. O positive group is taken from only the 2 O positive and the O negative. Next, last, I'm writing here, O negative, taken the blood from which one? Only the O negative group. That's why we call as a, it is given to the all the groups, but it taken from only the same group. That's why we call as a universal donor. Universal donor. The AB positive group is called as a universal recipient, means for this all the groups are suitable from the all the groups, they can take the blood. That's why we call as a universal recipient. What about the universal donor? They can give to the all the groups, but they can take from that group only. That's why we call as a universal donor. Here, this one is about the compatibility. Next, I am drawing the table. Then you understood detailedly. The means in the exam, if it is this question will come, you draw the table easily. You can get 3 to 4 marks. That's why just to practice this table. Blood group. First, blood group. Are also called as a phenotype, and here the genotype, and next the antibodies. So first antigens present on RBC. Next antibodies present in plasma. Next, can given to can taken from see this one. Next, this is also called as a phenotype, and the blood group are also called as a phenotype A, B, AB, O group. Next, here the genotype means they may be the A group is having the homozygous, means IA, IO, maybe heterozygous, that is the IA, IO. That is the genotypes of the A group is 2 are there, and also next B group is having the IB and IB homozygous, IB, IO heterozygous. Next, the AB group is having the IA, IB. Already we discussed about this genotype. Yes. Next is the IO and the IO. Here the one more thing. Here the multiple alleles. The both of them are means IA and IB. Both of them are dominant on the IO. Means if for example here the B allele is there, O allele is there, but B group only expressing. That's why it is a dominant character. Means the A and B dominant on the IO group. For example, O is coming, the before which one is there, that only expressing here. But the IA and IB is a co-dominant. The both of them are equal, but they if IO is coming, they are dominant on that. Here, that's why here this one is about the genotypes. Next is the antigens. The A group is having the, on the RBC, having the A antigen is present. Same group means next the B group is having the B antigen is present. AB group is having the A antigen and also B antigen is present. Here, next O is not having any antigen. That's why it is the universal donor. Here, next one is the antibodies. Here, antibodies, I am adding this anti reverse. This one is a, here it is a, here it is A is there. Here I am writing as anti B. Opposite antibody that is present in the plasma. Next is the B blood group is having the anti A. Next, the AB group doesn't have the antibodies. That's why it is a universal recipient. Here, for the attacking, no antibodies are there. That's why they can accept the all the blood groups. That's why we call as a universal recipient. This one is here. Next, the O group. O group is having the two antibodies are present inside of the plasma. They are the anti-A and the anti-B. Next, the A group. A blood group is given to which persons? Which persons? The A blood group is suitable means that is suitable to the A group and the AB group. They are only the two groups are taken from the AB blood group person. Next is the it is taken from the A group and the O group. O group is the universal donor. That's why they are taking. Next is the B group. B group person, they can given to the blood to B group person as well as AB group persons. And they are taken from the B group and the O group. Here, next is the AB group. AB group is having the, mainly AB group is given to the only the A group persons. It is not suitable to the A group person, B group person, O group. It is suitable only the A group person, but it is taken from the all the groups. Clear? All the groups means A group, B group, O group, and the AB group. Clear? That's why we call as the universal recipient. Clear? Next, the O group. Clear? O group. O group is taken first given to. O group is given to all the groups like A group, B group, AB group, and O group. Here, next, it is taken from only the O group. Clear? This one is, this table you are get perfect. Easily you can write the matter also. If you practice this table will be easy. Get practice this one. Then this table you draw for the multiple alleles, easily you can get 3 to 4 marks. Here, this one is about the multiple alleles. Next, this one is a one LAQ, first LAQ from the genetics. Next, I'm started the next is the LAQ, that is called as a chromosomal theory of sex determination. Next LAQ, this is also important. Chromosomal theory of sex determination. So normally the animals sex determination is mainly occur by the one pair of chromosomes. Here, one pair of chromosomes determine the sex. Here, in any one organism you can take, the sex determination is occur by the one pair of chromosomes. These chromosomes are called as allosomes, are also called as sex chromosomes. Allosomes are also called as sex chromosomes. Means sex determination is mainly occur by the chromosomes that we call as a allosomes are also called as a sex chromosomes. For example, in the human being, 46 chromosomes or 23 pairs of chromosomes are there. In the 23 pairs of chromosomes are the 44 plus XX present in the female, 44 plus the XY is present in the male. Means these one pair is the allosomes are also called as a sex chromosomes are 22 plus XX are the 22 plus XY chromosomes. Like this, they are the one pair of the chromosomes are determine the sex that we call as a allosomes are also called as a sex chromosomes. In the chromosomal theory of sex determination, they're having the two methods are there. The determination is by the two methods are there. One is called as a male heterogametic. Male heterogametic method. Male heterogametic method of sex determination. Second one is the female heterogametic method. Heterogametic method. Here it is a why we call as a male heterogametic means the males are having the heterogamous means males are having the only one chromosome or the different chromosomes are present that we call as a heterogametic. That is called as heterogamous is present in the male, then we call as a heterogametic method. If the heterogamous is present in the female, that we call as a female heterogametic. Male heterogametic in these two are there. They are the XX XO type of sex determination, XX XO type of sex determination, and the second one is called as the XX XY type of sex determination. Two types in the male heterogametic method. Two types are there. They are called as a first one XX XO type of sex determination, and the second XX XY type. Here this one is the male. These are the heterogametic is there. They are called as a male. That means here the females are having the one pair of X chromosomes. The males are having the only one X chromosome is present. That's why it is called as the male is having the different chromosomes. That's why we call as the male heterogametic method. And the detailedly I'll explain about the types. Next, female heterogametic is also having the two types of methods are there. They are called as a ZO, ZZ type of sex determination. And second one is the ZW, ZZ type of sex determination. Here, the females are having the heterogamous. In this, the females are the heterogametic in condition. That's why the ovas are determine the sex in this one. Here, in the male heterogametic, sperms are determine the sex. Here, detailedly, I will take the chromosomal theory of sex determination is having the two methods are there. Male heterogametic method and the female heterogametic method of sex determination. First, I'll take the first one, male heterogametic method. Male heterogametic method are also male heterogametic sex determination. Yeah. Next, in this, see this one. First, I am taking as a first one that is called as the XX XO type. In the XX XO type, the karyotype of the organisms is we are adding the autosomes. This is the AA XX and AA XO. Here this type of sex determination is occur in the bugs, grasshopper, and cockroaches. See here, the table, I'm writing the table. This table is important. Observe this table. I'm writing as a karyotype. What it is? The AAXX. AAXX. This one is I'm writing like this. This one is a female. Female is having like this cross with male. AAXO. Here the males are the heterogametic. Already I said males are having only one X chromosome. That's why we call it the heterogametic. Next here the females are having the two chromosomes are there. That's why females are the homogametic. And how they are means they are producing the here they are producing the ova here. They are producing the ova. These are producing the this called as a ova. Which type of ova is present means all are AX type of the ovas are produced. These are the ova. Next is the this one is producing the this is the male. This is producing the sperms. Taking another color. These are producing the sperms. Here, all the ovas are same. The producing female is producing all the ovas are similar, but here the sperms are different. Here, the 50% of the sperms are having the AX, and another is having the AO. Here, next you join this one. If all the ovas are same, but the sperms are different, what it is means here they are AAXX. The next generation it is having the AAXX. It is called as a female. Next, the ova is attached to the AO sperm, that is formed it as a AAXO. Means which one is determined the sex here means the sperms are determined. Sperms are determined the sex. The sperms attack to the which sperm is attacked to the ova, that type of the offspring only. For example, the sperm is AX that attached to the ovum, the female will be produced. If the AO is attached to the ovum, they are producing the male. That's why who determine the sex here means the males are. Which one is a heterogametic? Male is a heterogametic. That's why male determine the sex. This one is about the XX, XO type of sex determination. It is present in the bugs, grasshopper, and the cockroaches. Next type. Next in the male heterogametic only. The next type, next is called as a second one. XY type. XY type of sex determination. Here the karyotype is the AAXX. AAXY. Just simply you are adding the autosomes. That's all. For this you are adding the autosomes that we call as a karyotype. Here. Next, this one is a female. Normally same like the before. This one is a male. Next, same. These are producing the ova. These are producing the sperms. How it is? See, these are the ova. All are same type, and these are producing the sperms. 50% of the sperms are having the AX chromosome, and 50% are having the AY chromosome. Here, AX. This one is all the ovas are similar. They are having the AX. The sperms are different. 50% of the sperms are having the AX chromosome. 50% are having the AY chromosome. Here, now we are adding, see this one, like this. The AX sperm is added with the ovum. They are producing the female. AAXX. This one is the female. Next, this sperm, AY chromosome having sperm is the fertilized by the ovum that is formed as a AAXY type, means the males will be produced. Here, like this. In this also, the who determine the sex means if the sperms are determine the sex. Which one is having? Here the heterogametic is present in the male only, that males are determine the sex in the before XX4 type of sex determination, and the in this XXXY type. Here this type of determination is present in the human and Drosophila. This type of sex determination is present. Here the tables are very, very important. You understood the table easily, you can write it the matter. Here, next type. Female heterogametic method. Here the two types are there. First type I am taking ZO, ZZ type of sex determination. ZO, ZZ type. It is present in the butterflies. This type of determination present in butterflies, and the karyotype is same. Before we wrote now like that only. Write it AA, ZO cross with AA, ZZ. Here, this one is this one is a female, and this one is a male. Same. The ovas are produced. Here the two types of ovas are produced. Before that, only one type. Here the two types of ovas are produced. One is having the AZ chromosome. One is having the AO chromosome. Next, it is here. Next, here all the sperms are same. They are having the AZ chromosome. Here, the means before that, the sperms are 50% of the sperms are different, 50% are different. But here, in this condition, female heterogametic method, female producing ovas are, these ovas are dissimilar. All the sperms are same. All the sperms are same. This one is a dissimilar. Here, they are adding this. See this one. Here, AAZZ. Means this one is a male. Next, this ova is adding the AAZO. This one is a female. Here, in this, which determine the sex? Female is determine the sex. Why means female is a heterogametic. The different is there. That's why we call it a females are the heterogametic in condition. Next, this type is present in the butterflies. Next, last one, in the female heterogametic, the second one that is called as a ZW, ZZ type of determination. ZW, ZZ type of determination. In this, what the karyotype? Same like that one, AA, ZW into AA, ZZ. Here also, this one is called as the female, and this one is called as a male. The ovas are produced. These ovas are different ovas are formed. One is called as AZ, another is called as AW, and in this the sperms are produced. All the sperms are carrying only the AZ chromosome. If they are adding, see this one, here it is a AAZZ. This one is a male, AAZW. This one is a female. Like this, the means in this also the females are determined the sex. Ovas are different, but all the sperms are same. This type of determination is present in the reptiles, birds, and some fishes. Here, this is about the chromosomal theory of sex determination. Today I explained the two LAQs, multiple alleles and chromosomal theory of sex determination. You practice it. This one is a very important question. Here, we will meet tomorrow same this time.